My presentation is just going to try and bring a couple of key points that Peter and also Ben mentioned, but in reference to mining, and I think picking up on a point that Jack made earlier, there are elements of great stuff in the mining industry. It's just not perhaps as prolific as we'd like it to be. And as we're going through, there'll be a couple of slides just on some of the questions you've answered, just to see if there's any comments you might like to share as well. So firstly, people ask, what's a system? How big is a system? So my response often is, if we think about the auto industry, it had a small view of what a system was in the early days, in the 80s. And as time progressed, they broadened that scope. And nowadays, you've all heard the stories where they've got suppliers coming in, fitting windscreens in the production line and managing inventory. So systems grow as the maturity in an industry grows. And it could be as broad as, cradle to grave in the mining industry, time we find an asset, a deposit, to the time we retire it, or it could be smaller than that. In most cases, and for the purpose of today, I'd like to just focus on the operating asset. One operating asset. It could be more than one, but for today, if we could focus on that, just to illustrate some points. We all know the S-curve. The S-curve is there to understand how over time, for the effort that we put in, we can improve the outcome. And systems can be measured that way. But how do we know where we sit on that S-curve? So typically, what people tell us is that the outcome, the output of that, whatever ambition is, has different distributions. The lower down on the S-curve we are, the tail will tend to go out to the right. The higher up we are, it'll tend to bunch up, assuming that to the right is good, the good end. Does it make sense? It's pretty straightforward stuff. And somewhere in between. So how do we know where we are? Well, we can measure that, can't we? Any output that you're looking at from a system, you can measure it and you can see that distribution happening and make some assessment as to roughly where you are. Down at the low end, we talk about, in circles we've discussed this, as a substitution, which means that quite often we get a technology, we plug it into our process or system, and we don't do very much different stuff with it other than it substitutes for what we already do in a different way. So, think about note-taking manually with a piece of paper and a pencil or a pen, or getting an iPad. It's the same sort of concept. However, the further up you go to extract value, we start to modify within that system. We modify things within the system. Peter talked about, once you find a constraint, getting into that constraint and liberating it with certain, business improvement tools and the like. If we take a simple example of a car, for instance, so, down at the low end, you might have what's a typical car now? Say, let's go for a Ford Cougar. We've solved the fire problems. But it's an old version, and it doesn't really get up to top speed. Maybe, top speed's about 120 k's an hour, right? And we want to get from home to work in the fastest possible time. We live somewhere out at Pretoria, and we're heading to Joburg every morning, right? So 45-minute trip. Now, we might try and do a couple of, then someone comes along and says, listen, you know what? I can sell you a 3 Series Beamer, turbocharged. It'll do the job faster. So you go and buy that, spend a bit of money, you hop in the car, but nothing appreciably changes. Why? Because the system has, limitations within it. The car may go faster, but there's traffic lights, by the way, traffic lights, not robots. The only robot that anyone could qualify as a traffic light lives in, anyone know? Lubumbashi. Yeah, thank you very much. That's the only one. Other than that, traffic lights, dear people. Anyway, so there's the traffic lights, there's pedestrians, there's, all those, laws, all of those limitations. So it's not until we start to modify that process within the system, that we can actually truly exploit, the wonderful dynamic benefits of that BMW. So start building overpasses, a more direct road, less stops, and so on and so forth. In the substitution area, you may accelerate a bit faster, but that's not going to get you an awful lot. 0 to 100, and then you've got to slow down again. So that's the difference. Then, once we exploit the entire system, then we start to look at, well, what are we going to do different? Because now we're at the top speed, we've got to come up with something else. And it may be, and totally typically it's a new technology. We go and buy, I don't know, the latest Bugatti, well, maybe a Hyperloop, helicopter, or a Formula One car, which I'd prefer first. But, it's that sort of thing, a new technology, and the process starts again. We all know, though, that in the main, this is sort of what happens, relatively, right? We go and invest money in a new technology before we even exploit the opportunity of the old. So that's typically what happens, I guess, in, our experience that we've had. Here's the results of the question: how does your current operational performance compare against your operations design potential? How well do we think we're going? And most people reckon that it's on average there. Let's have a quick conversation. What do you think? Are most people operating at above that modification level, do you think?
Am I working in a system that is busy changing, or am I working in a system that is stable? Because if I'm in a stable system, the chances are quite good, I think, that I'm higher up the curve.
Right.
If I'm in an environment where we are constantly changing, it's like moving goalposts.
So maybe just elaborate on constantly changing. Is it
you're
intentional?
introducing new intentionally.
Okay.
Intentionally.
Any other thoughts?
So the question is, are you looking at the whole system or part of the system? So in mining, what we often see, or certainly my experience has been, we tweak the plant, and then we forget that our biggest constraint is actually our mine. So which bit of the system are you looking at?
We're talking about the whole system. Yeah. And that's exactly the reference Peter earlier made around silos. Okay, so let's have a look further then. So if we have a look at this operational asset, what we've been preoccupied a lot with over the recent past, I think, in the industry, is we're trying to we're linking outcome, high-level, strategic ambition to practical, detailed, granular metrics of some sort. So, how many tons of this, or how many movements of a truck, fill factor, cycle time produces the outcome type of thing. And we're building all of that together. And it's really a mathematical model. Some people are using it to start to drive and identify where root cause analysis, or where root causes may exist, things to focus on. But there's a big inherent limitation in this approach. And the key inherent limitation is what Peter was talking about earlier. We tend then to focus vertically in silos to optimize. So you get often technical people in the organizations coming along and saying, you've got to, improve bucket fill factor in a piece of or a fleet. And someone else says, no, but we need better drilling speed. And if you follow what Peter was talking about, one of those is a constraint, or should be, ideally. And quite often, what this doesn't pay attention to is that there is inherent variability throughout the process. And when that variability starts to affect or have a limitation on a constraint within that, then that's a bit of a problem. We've got to deal with that. And that's what Peter's largely discussion was about. So everyone gets that, I think. However, the additional challenge is this. There are human factor processes or systems within all of the systems, probably more so in mining than most other industries. They're the processes of planning, strategic through to short-term, scheduling, resourcing, to making sure that we've got what's required when we need it. And then how do we do the work execution? And in most cases, those aren't even understood or defined very well, let alone measured. So, let me give you a quick example, for instance. So my background is mechanical engineering. Many years ago, we, in the steel industry at least, were focused on optimizing asset life. So what do? We set up an asset strategy. What's involved in an asset strategy? A decision on how you're going to operate the equipment and how you're going to maintain it. There are four different operating models or focuses on that. One is operate to failure. Everyone's familiar with that. We don't care. We're just going to run it, fail, and replace it. Two is a duty cycle type of system where you look at how many times it does something or how long it's travelled, and then based on a certain, set point, you go and replace it or do some maintenance to it. Three is a fixed time basis. Do it every 3 months, do it every 6 months, whatever it is. And the fourth one, which is usually the more sophisticated, condition-based monitored, right? So we're going to watch it, measure it. When it hits a certain point, we're going to replace it. What's the purpose? And, we're coming back to some of the points that Peter and Ben made. There's a process associated with it, but it's not about the process. It's what's the purpose of doing this? The purpose of doing this is to avoid unexpected failures of equipment. Would you agree? That's why we do it. Generally, we don't want, and increase availability, obviously. So here's the thing. What if now in our system, we had a look, we've realized that, say, drilling is an issue. Drilling is the constraint, and we want to fix that up. We look at availability, that pops up. Availability, the amount of hours per week that we've got that fleet available. Say 50% of the availability is due to taking the equipment down for regular maintenance, as is deemed by the OEM. The other 50% is surprised stoppages. It fails for some reason or other. It stops. Breakdowns, in other words. Unplanned downtime. What are the reasons for unplanned downtime? There are 3 different ways that it can happen, maybe 4. One is that it's used outside of its design parameters. 2 is that the work that we did on it the last time, the time before, and the time before that was of low quality. We didn't do it well. 3, that we didn't use the right parts, the genuine bits. And the 4th one, anyone guess what the 4th one might be? The initial target was wrong. Talk more a bit about that. Let's elaborate. What is it specifically? A little more. What do you think? The strategy was wrong, right? We may have had a condition-based strategy that failed us, or a fixed time to replace that failed us. Now, let me ask a question here. In any of the organisations that you have any association with, how well do you think that is understood and measured and captured? And in most organisations that I've had the opportunity to work with in the mining industry, it isn't. I mean, I asked the question just this last week of an organisation. I said, so where does the responsibility and accountability for breakdowns rest? The typical thing is they didn't really understand how to measure that. So one of the biggest challenges we have is how do we measure those human factor processes and assess whether it fits, the fix fits in a planning situation or in a execution process. The same can be said of mining. We do a great plan, long term, medium term, schedule it, and the miners go and mine whatever they want. Why? The plan's no good. But do we ever know? And quite often we can't actually make that, empirical sort of deduction. So one of the biggest challenges is really those human factor ones. And to add to that, if we don't measure them, how well can we actually fix them and control them and have people to be accountable for them? And here's the big challenge. How many of you also see that in most organizations, seems that everyone is working at levels below them quite often too frequently? It's because these systems aren't set up properly. So now I'm worrying about, as a GM, and I've seen this, hour by hour, how many tons are coming out of the pit. Too late. The system needs to be such that I'm figuring out how to fix that process of planning, scheduling, and the whole thing, not the outcome of the tons coming out of the pit, because that's gone, that's finished. So it's, my job as a GM should be forward-looking 3 to 6 months, maybe even longer. And I need to be able to do the things that Ben was talking about in the All Blacks system, focusing on how do I now make sure that over the next 7 years, we've got that system so licked that I know exactly where to pull the levers to improve it. And that's one of the big areas that we're not focusing on sufficiently. And that goes back to measures, KPIs. How do you align them? Who do you make accountable for them? At what level? So here's, again, one of the survey results for question 3. Question 3 was all about how well do you think your company's KPIs at all levels of your organisation are sort of linked? Anyone want to answer that question?
In our company, most of you know, we was Anglo-American. When we started introducing the new operating model, we went through a structured process of really determining what's the purpose of each process and each process step. And then you often find that the KPIs that most of the mining industry is using to measure specific outputs are not helping us in achieving the purpose of that step. It mostly measures either historical performance or it doesn't measure the right metric at the right level. So, for example, an operator on a drill rig cannot be measured on the number of meters he's drilled, because he's going to drill either over drill, under drill. He's going to drill deeper in soft rock, shallower in hard rock, and you're going to drill up stuff of your drilling pattern, which means your blasting is going to be inefficient, load and haul is inefficient, bench prep takes longer on the bench below, and the whole system breaks down. So it boils down to understanding which person in the organization is accountable for direct operation and inputs, in other words, into a process, and then who's accountable to be measured on the output of the process and what do they do with that metric, as opposed to incentivize somebody at a lower level to achieve a higher level objective.
And we often think about accountability. Well, one of the challenges with thinking about accountability is those people that can actually have an influence or an effect on the outcome. Quite often we don't line that up very well as well. So the conclusion really is that there's a couple of things that we need to do to be able to better establish or understand and establish the systems in business, in our businesses. The first one is measuring that, that distribution of the objective function, if we want to call it that, or of the ambition that we have for that system. And what does that look like? And where on that curve are we? And then starting to look at, well, what have we got to do? When we talked about, for instance, the asset strategy for maintaining equipment, it's a fairly complex issue. There's a lot of different levers that we need to understand and pull. It's not hard to model, but we do need, and Peter talked about it earlier, a dynamic model of the system. Because it's not a fixed, just mathematical fixed model. It's a dynamic model that changes over time. If we do identify where and set up where the constraint in the system is, makes it a little easier, obviously, but we do need that dynamic model. Also to determine where the dependent variation has an effect. The third thing is this alignment of measures and accountability. Again, Peter mentioned if you want change, You want to see people change, do a different thing to what we did before for a different result, a better result, fix the measurement. Nothing incentivizes people better than fixing the measurement. But fix the measurement in a way that does make sense, that it does connect through, and that people have an ability to influence and improve it, or, get a better result. And then the last one is around configuration. So configuring the system, being all the processes within the system, including the human factor processes, because that's what we see is lacking is, how is the quality of those human factor processes being achieved? One of the big challenges, I guess, in the mining industry is because we're not as automated as manufacturing, human factor systems are much more impactful on our day-to-day results and ongoing results. So we need to address that. And in some cases, we need to completely design them. In other cases, it may be just a reconfiguration. That's brought me to a close. Thank you.